Welcome to the new topic, Module 1.7, Fractions to Decimals, Decimals to Fractions. This is highly essential. You have to memorize the techniques for you to understand 11 plus maths, Key Stage 2, Year 6 maths, Key Stage 3, and as well as GCSE. So if you understand it from now, you're going to do extremely well. So we're going to teach you how to convert, say, this fraction into a decimal and vice versa. That's what this module 1.7 is about. So let's begin. So we're going to have a quarter. A quarter is this. Put a circle here and shade 1/4. That's what a quarter is. Now to convert that into a decimal, either you memorize it or you do this technique. You create the long division symbol here, and you put this numerator, which is the 1, in the box, and you put a dot and you put a 0 here. When you place the dot here, you place another one here, adjacent to it. Now you put this denominator here. So in essence you're saying how many 4s go into 1. Now how many 4s go into 1? It doesn't go, so you put a 0 here, so you've got 0 point, and then you combine this. How many 4s go into 10? It goes in twice with a remainder of 2, because 2 times 4 is 8. 8 minus from 10 is 2. So now how many 4s go into 2? It doesn't go, so you put a 0 here. How many 4s go into 20? Goes in 5 times. So 1/4 is 0.25. Does it make some sense? Let's try another one. Okay, we've got 1/3. Again, you create the long division box. You put the 1 in the box. Put a 0 and a dot, and you put a decimal place here. Now you put the 3 on the outside. How many 3s go into 1? Doesn't go. How many into 10? Goes in. 3 times 3 equals 9, with a remainder of 1. Then you put a 0 here. How many 3s go into 10? Again, 3 times 3 is 9, with a remainder of 1. Go in again. 3. So this is called a reoccurring decimal. It will just go on and on and on. So you can write it like this, with a dot on the top, which means it goes on and on and on forever. Makes sense? So if we do 1/5, nice and easy one. Try this. Pause the video and try it. Okay, welcome back. We put the 1, always put the numerator inside. Then you put a decimal place, you put a 0, you can put more zeros if you want. Now we're going to put the denominator, so 5 goes here. And how many 5s goes into 1? It doesn't. So how many go into 10? Exactly 2. So the answer is 0.2 or 0.20. Very simple and easy one to do. Now what happens if it's 2/3? Now 1/3 was 0.3 recurring, went on forever. So doubling this to get 2/3 means it will be 0.6 forever. How do we do that? Put the decimal place in, put the 2 in, put the decimal place, put a decimal place here, put the 3 here. How many 3s go into 2? Doesn't go. How many into 20? 3 times 6 makes 18, so 6 times, with a remainder of 2. How many into 20 again? 6. How many into 20 again? 6, sign of the devil. How many into 20 again? 6. So it goes on, 0.6 with a recurring point on the top. Now, here's something that we need to know. Let's say if it's 1/6. So we do it again. Put the 1 here, put the decimal place, put the zeros here. You could do more than 1 0. Put a 6 on the outside. How many 6s go into 1? Doesn't go. How many into 10 goes in once with a remainder of 4? How many into 40? 6 times 6 is 36, so 6 times with a remainder of 4. Again, how many into 40? 6. Remainder of 4. Again, you'll keep on going. So the answer is 0.16 with a dot here, which means it goes on forever. It's called a reoccurring decimal. It goes on forever. Okay? 1/7. Put the 7, put the 1 here. Decimal place, 0. Let's put some zeros, put the 7 here. How many 7s go into 1? Doesn't go. How many into 10? 1, so with a remainder of 3. How many 7s go under 30? 4 times. 7 times 4 is 28, with a remainder of 2. How many go into 20? 2 times, with a remainder of 6. How many go into 60 comfortably? 8 times. 8 times 7 is 56. So now it's going on, and it's going on with different numbers. So what we say is you can do it this way, 0.14. If we say to 2 decimal places, it's 0.14. To 3 decimal places, it's 0.143. So in the test, we may say 2 decimal places, it's this, 2 dp. And if it's 3 decimal places, it's this, 3 dp. Notice how this becomes 3, because the 8 here is 5 and above, which makes the next number on the left go up. We will be covering decimal places in a later module. So, to speed up things, one should memorize this, these are common ones, this, 1/8, 1/9, 1/11. These are common ones which should be memorized, which we did in class last week. So you should definitely memorize, and it will come up. 100% this is coming up in the test, so you should memorize what it is, and if you don't, just work it out, and I've shown you how to do that. Now here's something else that will come up. If, for example, we say, here's 3/20. Now convert that into a decimal. You could do this. You could put the 3 here, put the 20 here, and go through this procedure. This will take a long time. However, you could do it this way. We are going to make this 20 into 100. So how do we do that? You times it by 5. If you times the denominator by 5, you have to times the numerator by 5, which makes 15. Now, 3/20 is equal to 15/100. Now, to convert that into a decimal is very simple, because 15 divided by 100 is equal to 0.15. Hence, your answer is 0.15. So this technique is quicker than this technique. Why? Because all you have to do is make the denominator equal to 100. So the key is, if you see the denominator equal to 20, then you make it into 100. If it's equal to 25, you times it by 4 to make it into 100. So let's try another one. So we have 7/25. What is that as a decimal? Well, to make this into 100, you times it by 4. Hence you times the top by 4, which makes 28. Now, 28/100 is 0.28. And that's how fast you can do these conversions. So please bear that in mind. It works if you have a 20, if you have a 25, If you have a 10, it works for it. And if you have a 50, you just times it by 2. So just watch out for these ones. Alright. Now in your test, you're going to also be tested like this. You have 2 and 1/4, and you need to convert that into a decimal. So it's a whole number with a mixed fraction. So a whole number with a fraction, which makes it a mixed fraction, sorry. So the simple answer is, we know that 1/4 is 0.25, yes? We know that. So all you do is put 2.25, and that is the final answer. You're basically adding that 0.25 to the number 2. Makes sense? Let's do another example. So we have 7 1/5. We know that 1/5 is 0.2, so you're adding it to the 7, which becomes 7.2 or 7.20. Doesn't matter. That's how you convert that mixed fraction into a decimal. That 7 is a whole number. Yeah, it's not a fraction, it's a whole number. Okay, that concludes changing fractions to decimals. You need to practice. Practice makes perfect. Right, now we go on to the next topic. So we're going to change decimals to fractions. So here's a decimal, 0.2. Here's a decimal, 0.25. What's the difference? The difference is, this is tenths, yes, and this is now hundredths. You've got the hundredths column here, yeah, hundredths. If it's just a tenths column, you do 2/10. 2/10, which means the tenths column. When you go over 10, it means the tenths column. So that can be cancelled to 1/5. Now in this situation, it's 0.25, so it becomes 25/100, which can be cancelled to 1/4. Please bear this in mind. If it's just a tenth, it's over 10. If it's tenths with a hundred, so it's basically the hundredths, it's over 100. Let's try some examples. So we have 0.7, and we need to convert that into a fraction. Because it's tenths, you do 7/10, and hey presto, that's your answer. Now if it was 0.75, it is over 100, hundredths, so 75/100, which cancels to 3/4. How do we know it cancels to 3/4? Because if you divide that 75 by 25, you get 3. You divide 100 by 25, you get 4. So what happens if it's 0.155? Then all it is 155 divided by 1,000. Makes sense? If it's 3 lots, that means it's got the thousandths column. So you divide it by 1,000, and then you have to cancel this. And the way to cancel it is to divide both numbers by one number, which is 5. Yes? So shall we try that? How do we do that? Let's try this. Divided by 5. 5 doesn't go into 1. 5 goes into 15 3 times, goes into 1, into 5 once. So you've got 31 here. 5 goes into 120 times. Yes? So into 200 it will go in 40 times. Into 300, 60 times. 480 times. You see where I'm going? 100 will be 100 times will be going into 500. So the answer will go into 1,200 times. How do we prove that here? Got 1,000 here, divided by 5. How many 5s go into 10 doesn't go? How many go into 1 doesn't go? How many into 10 goes twice, with a remainder of 2 zeros? So the answer is 31 over 200. This will be one of the tricky questions at the end of the paper. So bear that in mind. If it's 3 figures, 1, 2, 3, it's over 1,000, and then you have to cancel it. Okay. Here's one. 1.4. Very simple. We know that this 0.4 means 4 over 10, cancel to 2 over 5. So this will be 1 whole. This 1 becomes 1 whole with 2 over 5. It's a mixed fraction. Okay, so 1.4 means 1 2/5. Here, try this one. 1.95. So the 1 you know is a 1 whole. Now you've got 95. Because it's hundreds, it's over 100. Does it stay this way? No, because it can be divided by 5. 5 into 95 is 19, and into 100 is 20. So the answer is 1/19 over 20. And there you have it. That's how you convert decimals back to fractions. Now please practice for this Saturday's test.